Dun 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 dun. Hey there. Hi. We're live. We're live on Instagram, and if you're not on Instagram, if you happen to catch this on YouTube, Twitch, Facebook Live on a desktop or anything, you probably see all this crazy window around me. I've adjusted it for today. So if you're on Instagram Live, you're probably on a phone. You're probably looking at this screen right here, and that's all you can see. I did a quick adjustment so that I could not have to shift to the side, not have to shift to this side, not have to look awkward, look creepy, and just all around feel uncomfortable about my day. This is going to happen for about another 3 minutes while I talk through some of the things we've been doing this week. I'm super psyched. Oh my gosh, I don't even know where to start, but if you have questions, you're curious, I have had the chance to get extra super nerdy, and I love it. It's cool, it's fun. So, gosh, I don't even know where to start. The last couple of weeks, we've had a lot of cool projects. This started with 3D printing Christmas ornaments that we're going to donate, and there are things like these star-shaped ornaments. This is the prototype, just to make sure I got it right, with the loop to be able to hang some ribbon on, fancy ribbon to make the loop. Yes, 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 yes. Some tree-shaped things. Yeah, these were all the goofy little prototypes we made. Even like a basket, a Christmas ball ornament basket type thing where you can have Outlook tell you that it's time to do some Twitch stuff. Go away, Outlook. Thank you. Or you can create this basket. Like we can put candy in it or something. And look, it's even got our logo. You probably can't see that. Dun dun dun. Right there's our logo. Yep. There we go. Cool. So I'm down to 2 minutes on. Yeah, it is hard to see. But I'm down to maybe 2 minutes on in this little compressed Instagram view. But there's a whole lot more that we've been doing. In fact, today we were just discussing Saturday's Battle of the Bots, which was super exciting. I held a workshop with veterans to go through some 3D printing with one of my favorite VSOs, Wounded Warrior Project, and today's project to get them kind of into the world of 3D printing was this kind of dog tag thing. It says "Never Forget" on it because I try not to brand it with anything selfish. Yep, yeah, exactly. Oh, that could work too. But hey, so this was cool. This was fun, and these are being printed right now, so we can mail them out to the veterans. Once they do these things with us, I like to print things and actually put them in their hands so they can see not just the model, but also the things that happen. And a little bit of today, I'm gonna just chat. I don't have anything a formal scheduled plan, but I've had a lot of other projects going on, and I thought it was wise to share them. Everything from designing circuits from robots to my struggles with 3D printing. If you have been in our Slack channel, you've probably heard I got this printer bed, and it's been miserable having things stick to it. I've done so many things, and if we switch views here very quickly, you can see, poof, there we are. I'm actually printing with a new glass bed, and I'll do a little chat with that since I'm disappearing from the Instagram right now, actually. So that's kind of sad, but good at the same time. And on that note, check it out. So those are the prints that I was actually discussing earlier. That stuff is all set up. My second camera is working. Yay. And that means I can move on to some other projects now that I've solved this mystery of why wasn't anything sticking to my 3D printer bed. It was driving me insane. Let me mash some hotkeys and see what happens here. Oh, yep, there we go. Yes, we're back. I dig it. I've heard that I have noise in my mic. I think it is. Hold on. it might be the actual 3D printer running in the background. I'm going to turn down all the other things that it could be. Desktop audio. Hopefully you can still hear me. I still see some noise there. Might be a little low. Should probably be down a little, like that. Yeah, maybe that's better. Cool. Anyway, so there's a lot of... Oh yeah, no, the 3D printer is running in the background, and it's very loud at times. I need to adjust a few more things on it. I've gone through so many processes with this printer that it did not come ready to go out of the box, as you can imagine. So I'll probably talk about that first for a couple minutes. So do I have the hotkeys? Nope, not that hotkey. Dun dun dun. This one. That view's not set up on hotkey. Odd. So this printer, this Creality CR10 Mini, I really kind of dig the printer, but at the same time, it seems like everything that could have gone wrong with this specific version has gone wrong for me. I couldn't get things to stick. This glass bed here that you see on the little screen was the original, the factory-made glass, and it had a minor bow in it, and it was extremely minor, less than 100 microns, I believe. 0.08 millimeters was what I figured the bow was in the middle, and I didn't think it would make that big a difference. So I did some odd things. I usually use hairspray. Actually, I spray the bed. I spray that bed right there, and coat it in hairspray, and then heat it up to 70 degrees Celsius. Let it bake on, because hairspray. If you think about it, if you ever use hairspray mousse or anything, it gets a little sticky in your hands. You have to wash your hands after you put it on your hair, after you run it through your long golden locks or whatever you have going on for yourself. So it works really well on glass, and I've had great success with it. But on this glass, the original manufacturer's glass blade, I could not do that. Nothing would stick. I've had issues with the temperature. The temperature on this one seems to be about 20 degrees hotter than I'm used to on a similar model. So it's just been a very big shift away from the other Creality printer I had, and on top of that, I still need to do a couple things. I need to check the feed on the extruder. Ooh, as you hear that kind of like, I think the belts and the pulleys and things need to be tightened up. They seem to be very loud, and I thought it might be the motors, so I put dampers on the motors. That is not the case. I replaced some of the fans inside so that they were not as loud, and overall the noise has dropped. The sounds in the background are lower, and if you hear that pop, that click, that's an indication that the feed rate is off on the extruder. The little motor that's spinning in the background that's pushing the filament through isn't feeding at a rate that is consistent with the software and the firmware and all of the settings inside. So I really need to do just a few more minor calibrations to make this printer feel like it should feel. And there was another one of those pops. That's actually the the wheel that's spinning that's pushing through the filament. So if the wheel is spinning like this and pushing, I'll come back to this other view. So we have a wheel right here, and it's spinning, and it's pushing this filament through, and the filament can't go any further, so the wheel is clicking and popping, almost like a gear slips in a transmission. So instead of hearing the gears grinding, what you're hearing right now is in succession is that pop, 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 and it's annoying to me because it's eating away at a very thin edge of the filament, but also that just makes me anxious that the nozzle doing what it should be doing. It causes me tremendous worry and having to constantly look down and look at it and check on it and make sure that it's not about to start fire or any of those other crazy things. So it's stuff that can happen as we look back at it. So the glass that I have there, actually, I went to 2 hardware stores in the area, and nobody can cut glass here in Manhattan. It's extremely hard to find a hardware store that can actually cut glass. So I had to order a custom-made piece of glass, or specifically for this printer, and it has been night and day. It's been almost perfectly flat. It was very easy to level as far as a bed. Yeah, and if you heard that right there, that was the noise of not the motors, not the steppers or anything, but the actual mechanics of the printhead sliding across the rail. And I have narrowed it down to the bearings, which either need to be tightened on the wheels, or possibly the bearings, maybe there's a bad bearing in there that wasn't QC'd very well before it left the factory. But first, I'm gonna go with checking all the bearings. I'm gonna break it down over the holidays when I have downtime and I'm not using it to print things, so I can do like an extra good tear down on all the moving parts, and that's just the way it is, just how it's gonna have to work for now. But yeah, and if you hear that clicking, click, that click that just happened, that's the filament stuff. Click again, yes, and that stuff is more common on the way this is set up right now. You can see that white tube just in and off the top of the screen there. That is the tube where the filament goes from the motor that kind of feeds it in to the extruder and into the extruder. It's made out of Teflon, PTFE. It's very smooth, very flexible plastic tube, and the coefficient of friction for that specific type of material is very low. So it just the plastic slides through it. The filament, the little PLA line, just kind of slides through it without much resistance. And a couple weeks ago, I sat down. I showed how I actually broke all this down. I installed a new nozzle, cut that line to a shorter length, a lot of other things that really helped streamline this process. But the next solution, the next step in maintenance for this printer happens to be checking all the bearings to make sure that they're not loose, retightening the belts. There are 2 belts, one on the X and one on the Y axis, and after that I will probably have to remove every bearing if I still have issues, and figure out if maybe there isn't a bearing that's binding somehow. But those are just kind of little things, just the little parts of the printing. You know, it's going to happen with any printer. You can hear a little bit more there. You hear a mix of noises that you should hear. You should hear some of my stepper motor right there, but you'll also hear like a rattling, like a louder rattling over the printer, and that is what I expect to be the bearings. Either having a little bit of play in them or binding internally as you know, like they're basically like skateboard bearings, that type of thing. So they can go bad. It's just part of mechanics. It's part of physics. Yeah, cool. So, excuse me. I will just briefly mention those dog tags there were modeled after my real dog tags. We broke them out today. I broke out my dog tags, which I don't normally do, and we modeled a commemorative dog tag after one of my commemorative dog tags. It actually has a picture of my kids on the back, and it says "We love you, Dad," and all that stuff. And aside from the silencers that are missing because they're 20 years old, you know, I still have them. It's kind of funny, but I think aside from this project, which was fun, it was very cool, and it's always great to field questions from people today. That there were really good questions from veterans who all of a sudden realized, oh, this is easy. I really want to get involved. What kind of printer should I get? What should I be looking for features? What would you expect to pay for something like this or something like that? And it's very cool to be able to help people figure out that science and tech is not very hard at all. This stuff doesn't require degrees. It doesn't require anything other than a little bit of effort, a little bit of patience, a little bit of trying. Not Don't be afraid to fail, um, that kind of thing. So it's uh, it's cool. It's fun. It's fun to help people. It's always fun to lift people up with you when you do that kind of thing. And that's part of my good feeling and the reward I get for doing what I do here at the Lift and Shift Foundation. But we have other projects. Poof. Hi. Hey. How you doing? We have other projects, and I dig so many of them, but I don't have a lot of free time all the time to actually do some of the cool stuff. What I do have a degree in is electrical engineering. So I like to build circuits. I like to design things. I don't like the math part. I find it extremely boring, and any chance I get, I will just like make something and let it break instead of doing the math. I've been lucky to work with so many other really people who are just much smarter than me who also enjoy the same thing. The lab I work in, I tell people it's kind of like the Big Bang Theory in real life. We don't really do a lot of math. Well, we, we we do collectively, but I don't. I'm the engineer. I kind of like break stuff. But as an electrical engineer, sometimes I build circuits, I design things. I try not to build custom circuits though, because that's expensive and it's hard work. It's a very in-depth process to actually build a circuit board. And when I first went into a real research lab and started doing electrical engineering to support scientists in their experiments and their projects, I was so fired up to build a board and do all this stuff. And after 2 weeks, I sat down with our lab director and I said, well, here's all the designs I have. And we started talking about it. And when we started talking about a project budget and a timeline, I stopped and I looked at him and said, you know what? We're building these custom circuits, and why don't I just go grab an Arduino and hook it all up and see if it works instead of spending all this time on it? And that was like my epiphany as an electrical engineer that I'm probably never building another circuit board again in my life. It's parts are so readily available and so cheap and so multi-purpose in the ecosystem of devices that it makes no sense in most applications to build a custom circuit. If you're building a phone, like an iPhone, if you're building a blender, if you're building a commercial product, sure, I get it. That makes a lot of sense. But if you're doing research, you're building prototypes, you're designing something for around the house, grab an Arduino or a Raspberry Pi, and just make it work. Just connect some wires to it, get a battery, plug it into the wall, whatever you need. That usually solves my problems, and it helps me out a lot, especially with timing. I built a handful of devices now, and I love seeing other people make them work. I these days ask people, like, what else can I add to this thing? What else are you doing? What research? What science is happening? What could make this cooler for you? And those are the fun things, instead of spending my days doing math and designing circuits. But we do have a project to build a robot, and it needs a brain, and it's been on the shelf for a bit. And part of it being on the shelf was this printer right there. Yeah, this printer right there, giving me a lot of headache and heartache about making it go and making it work, because I'm gonna design the circuit boards for the brain that we need, without doing all the soldering and the struggling, because we want something that looks presentable and professional and almost like a commercial package. So it needs to be easily assemblable instead of me struggling with a soldering iron and all these surface mount parts for hours and hours at a time just to produce one board. We did this over the spring, and for me to produce three of our first prototype boards, it took me days almost. It was very very challenging for me personally to solder on all these parts, and using through hole soldering, snap-on boards with sockets and all this other stuff. So that's when I realized I really need to break out my engineering skills again and do that kind of stuff. But I don't worry, I've done this before. This is all part of the process of building things. We have a circuit design, so I'm testing the production capabilities that we have now that I have the 3D printer available. So if we take a step back to the 3D printer, actually I will share one of the, oh look, dun dun dun, there it is, it's done. Yeah, cool. And I'm just gonna let it sit there. There it is right there. You didn't get to see the fancy ending because I was, all blah 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 about me, but there it is. So check it out. I'm gonna come back to me, and I'm gonna share this. This is I think it's a 10 watt laser. It's an engraving laser. It's not a cutting laser, but it's a laser, and this laser attaches to the box, to the actual print head of my 3D printer. These are magnets right here. They attach, they fit on, and I have software so that I can use this just like a laser engraver. So I need my printer to operate the way it's supposed to. I've actually fried 2 motherboards trying to make this work before, and this is why I have this new printer, because things did not work over the summer. So note to all of you wannabe electrical engineers, do not trust that people on YouTube actually read schematics before you go plugging in powerful things to a mini fan port. That I should have broke out the schematics myself, but I thought I'd save some time by listening to some dudes on YouTube, and that was not smart. That cost me a few motherboards. But so my printer is operating the way I need it to now, so that I can actually cut things. And I thought I'd talk a little bit about this project, because it's gonna in January get back on the board for us as far as what we're tracking for cool fun projects. And part of it is having this laser to be able to cut not circuit boards, but all the parts to create circuit boards. And I'm gonna show some of the parts right now, because I find that to be fascinating for me. So, and I'm gonna explain a few options available for this too, because there's more than one way to do this. I'm not the only dude in the world. This is not my idea. That I'm following along with things that I've learned, that I was taught. So let's check this out. Look, this is a sample circuit. It is not the circuit. Oh, the light balance adjustment is terrible on this. I gotta change that sometime. But so I've got this circuit, and I can print it. So if I do this number, so the light doesn't go crazy, and hold it up like that, you can see this circuit that I have right here, and I can print it. I'm printing it on inkjet printer, but you can print the circuit in a way on a laser printer that you can iron the toner ink off the printer onto an actual circuit board. And what we do is we kind of create a mask. We create this cover over a circuit board, and once the cover is over the circuit board, over the copper there, you can use chemicals to melt away all the copper on a circuit board and leave behind this little tracing. It's called a tracing. It's called a circuit trace. And that's basically the process. You use a very very strong acid, usually hydrochloric acid, muriatic acid, something like that. Ferric acid used to be popular, I think, was it? But these days we're a little more eco-friendly. We use a ferric solution that there's some chemistry behind it, but basically once the reaction happens, you can keep using it over and over again, and it keeps more stuff out of our landfills. I'm down with that. I dig it. I'm not really cool onto just dumping everything I can into a sewer drain. I grew up on the Chesapeake Bay. If you've ever swam in the Inner Harbor in the Chesapeake Bay, you will appreciate the fact that we don't need to dump anything else into the ocean. Thank you. But on that note, so basically the process of creating circuit boards is you have a full piece of copper, just like this glass plate would be covered in copper, and you need to remove all the copper except these little lines right here. That's the entire process of creating circuit boards. There's two primary ways to do it. You can use a mill, an end mill, a CNC, computer numerically controlled, basically like a fancy super computer controlled Dremel tool to kind of like grind out all the copper, and that leaves these little shavings everywhere, almost like sawdust, and except it's copper, and it can get very messy and very loud and very hot as you're grinding off this stuff, and you have to replace the tools. It's basically very expensive drill bits that do it, and I'm here in my apartment. I don't know if anybody notices that or not, but I'm not doing that in my apartment. You can get devices. I think Bantam Tools makes a very small CNC mill for circuit board cutting. It's actually really, really small. I used to have one in the makerspace. It's really small. It's like this. It's I don't know, an 8x8 little box, but it's loud, and it takes maintenance and things. So the other option is to, when you have this circuit board covered in copper, you melt away. You create a chemical reaction where the copper goes into the acid. Copper is a strong base. Depending on where you find it in nature, to get into the chemistry, it's either like +2 or +3 as far as an ionic element type thing. It's been a while since I took chemistry, so you'll just have to trust me. Copper is one of those positive ions in a chemical makeup. So if you introduce a negatively charged solution like an acid, they will combine and mix, and the copper will leave that plate. It will merge with the acid and leave this plate. So that the basic function is you dump acid on the copper plate, and it removes the copper, leaving behind anything that wasn't covered up. So we need a process to cover the copper with these traces, with these little black lines right here. There's quite a few different ways we can do this. We could do the old school way of literally like stenciling out and tracing in tape those copper tracks, these little traces right here. We could try to cover them. Some people will go like specialty markers, all kinds of things that are out there to kind of trace this, if you can trace it. The other option is this was, somebody found this out maybe a decade ago. The process of printing a document on a laser printer involves a toner. Toner in a cartridge. It's not really ink. It's this like this toner, but it gets heated up and pressed into the paper so that it so that it sticks to the paper surface. And people have learned that it doesn't always, depending on the paper, it doesn't always actually stick. So you can just, and this is the same theory that works for t-shirt transfers. If you've ever printed a t-shirt transfer and ironed it on to a t-shirt, it's the same process, works for copper for covering up these tracks right here. You could print a t-shirt type transfer on a laser printer specifically because it has to have the toner, not the inkjet ink. And you can go through the process of transferring your circuit trace onto a copper board. It's super cool, super fascinating. It also requires a great deal of heat and a great deal of pressure, just like um, a laser printer. Laser printers get hot. If you've ever uh, felt the paper when it comes right off a laser printer or a copy machine, it feels warm, right? That's because it's been under heat and pressure to apply the toner. So that is one option. I'm not taking that route because I don't have a laser printer. I have this little tiny inkjet printer right over there, and um, I, I I think it's cool, but I also don't want to do the whole heat and pressure thing because it would take some trial and some error to set up, and then you have variables like how hard you press and all this other stuff that you could change theoretically from time to time. I want something more consistent so that I can develop circuit boards with a specific process. So what I'm doing is I'm creating traces of these circuits on a stencil that I can spray paint over, basically. So what I will end up doing in the near future is setting up my laser printer, or my laser etcher, my laser, not laser printer, but I will be attaching this laser to my 3D printer and mapping out on basically transparency paper like this. This is not specifically transparency paper, but it's heavy duty um, acetate film that I recently got, and I have two different versions of it right here, just like this. And what I will end up doing is putting this down on my print bed. I'll be putting this down. Let me show you. That film will end up going right there on the bottom on that white plate, on that's the glass plate, and my printer will cut out all of this. So I will turn this into G code, which is the code that 3D printers use to map out your 3D object, just like that dog tag on my last screen. And what I'll end up doing is opening this in the printer manufacturer's software, and I will create a trace of this in just black and white that gets cut out of this sheet of acetate. And the acetate will then, just like a stencil, be applied to a full copper plate, just like this. But it'll be covered in copper. It'll be like a circuit board, like a real circuit board covered in copper. That's the one thing I did not grab before we started this, and I just didn't have time to hunt it down. But the copper plates are very easy to find. They're not too complicated to work with. But once that's covered, I will spray the stencil, the covered stencil, with a rubberized coating. Plastidip is actually what I've been using. I have several colors of it, versions of it here. Spray paint type can. It is basically liquid rubber, and excuse me, it will not dissolve as quickly as the bare copper. So as I spray paint this track, as I put it away. Why would I do that? I don't know. But as I spray paint this track all over my bare copper board, I will then be able to dunk my circuit board in a solution that will etch the copper away or eat the copper away, or it will be an acidic solution, and it will eat some of the rubber too, but not quite as aggressively. So depending on the solution I do use, it will take anywhere from a minute to 30 minutes to remove the copper, leaving behind just the little black part, my little traces. And after that happens, then I'll clean it. Obviously, because you want to wash away the acid, so you're not burning yourself. But also clean it with a brush. That way, I can brush off the rubber, leaving behind only the copper. And that will be the process that I dig into for creating custom circuit boards here for us and for me for whatever projects we happen to be doing. And well, it all kind of hinges on being able to use this laser, which was a challenge for quite a few months while I was, frying motherboards and everything else. But that is a process that is a good process. You can go to Instructables. I've seen at least 2 different Instructables showing you how to do these things if you're interested, if you're curious. You can just Google etch circuits, etch copper, and Instructable, and it will pop up. I guarantee the one will show you the laser printer process, which is it involves breaking out an iron and possibly printing on old magazines instead of regular paper. So that way the toner doesn't stick to it. The shiny glossy paper requires different heat and pressure. So that's the deal behind it. That's the science behind it. But anyway, yeah, it's not very hard to do these things, to make these things. But if you don't have the space and the process and the equipment, it seems impossible. But I dig all of this stuff. I love doing that stuff. I think it's fun. It's a blast. And in January, I'm excited to pick this project back up where we put together a few custom circuit boards. And instead of soldering together, looking through magnifying glasses, wanting to pull my eyelids off, I will be creating surface mount boards where 90% of the parts will actually be painted on and heated up. And that will also require something called a solder mask, which is basically the same thing. It's cutting out the same transparency, but instead of cutting out all those copper tracks and everything else, it only cuts out the parts where you would put solder on a circuit board. So any part you would add, a transistor, a resistor, a switch, a battery terminal, all of those parts you will have an opening for, and you will brush on a liquid solder and set all your parts on it and heat your board up so that it all kind of solidifies together into a working circuit when you take it away from the heat. And depending on the materials and that you're using, the different temperatures, different times, all that kind of stuff. So I can't tell you and I can't show you yet, but that will definitely be part of next year's steam engine type thing magic that I will do at some point in time. We'll be breaking out the iron right here and setting little circuits on it and putting on my solder mask and adding parts to it, letting you see right here on the work desk how custom circuits get made. I'm super fired up for it, but all of that starts with having the printer and being able to slice up not just the traces in a way that I can etch them, but also a solder mask, which is looks exactly like this tracing mask, I'm going to call it, but only takes into account where you would put solder on a circuit board. And usually solder looks like a little piece of wire and you melt it and that kind of stuff. That is not the same procedure for surface mount parts as it is for through-hole parts. So it takes a different bit of skill and a different bit of learning to be able to piece together very small boards with parts that are this small. So I'm excited about that, and I dig it. And I was honestly shocked here to see that this printer stopped, and I've been here for 40 minutes yammering on about all this stuff, so I'm gonna hop off. check out this batch, maybe squeeze in another batch before I hit the sack tonight, and tomorrow I can get back into printing before I disappear and close down and go visit my family. But I am excited to smash some robots together on Saturday. So come and join us. Come hang out. Come do stuff with us because, like I said, we're not just building robots here. But on Saturday we'll set up the arena again, and we'll have our 2 Ranger tanks duking it out on another sumo battle, which should run much better than last month. If you caught any of that, there's a replay around. All right, I'm done. I'm excited.